Alright, we have to learn how to make some basic momentum problems. So let's take a look at this example. We're going to run through it totally together. It says here that right is positive, so let's just make that change really quick. This is going to the right, so it's positive. This is going to the left, so it's negative. Great. What is the momentum of the 4 kilogram cart? Well, we know momentum is m times v. But since there's 2 carts, we should call it momentum of the first cart by saying P1, and that's going to be equal to m times v, but more specifically it's the mass of the first cart times the velocity of the first cart. So we're going to call that m1 v1. So this is m1 and this is v1. So we take that and multiply each other, we get 4 kilograms times 3 meters per second. That gives us 12 kilogram meters per second. Great. What is the momentum of the 6.0 kilogram cart? Well, we're going to call this the second object. So let's set up the equation for the second object. We need the momentum of the second object, so we call that P2, which is going to equal to m2, the mass of the second object, times the velocity of the second object. So here we find mass of the second object, and here we find the velocity of the second object. So we take the 6 kilogram times the velocity of the second object, which you might have put down 3, but it's actually negative 3. Make sure you plug that into the calculator, and if you do, you get negative 18 kilograms meters per second. Great. That was pretty easy. The hard part comes when we have to find the total momentum of the 2 carts. Well, to find the total momentum, we just take the 2 momentum and we add it together. So we take momentum of the first car plus the momentum of the second car. And I know from doing all of this work that the momentum of the first car was the mass of the first car times the velocity of the first car. Momentum of the second car is mass of the second car times velocity of the second car. And since I already did the math here, I know it's 12 plus negative 18, and that will give me negative 6 kilogram meters per second. So we know the total momentum here is going to be negative 6 kilograms meters per second. It says here that the 2 carts have blank momentum from each other. Now here you have to see that the first mass and the second mass are separate from each other, so they're going to have separate momentum from each other. So we're going to write down separate momentum from each other. Great. So let's move on ahead. So it says to find the total momentum of 2 objects that are separate from each other. Remember that this is the equation for when they're separate. We're going to need to use the equation that we just used. We realize P1 plus P2 is the total momentum, and this is the equation that we found of separate momentum. So to find the total momentum, we just take mass times velocity of the first object, which is that, plus mass times velocity of the second object, which is that. Great. However, we have a lot of times to actually need to find the velocity of the carts after they hit each other. So to do this, we need to find the total momentum before the collision and the total momentum after. We always need 2 sides of the equation. We need a before side and an after side. We need a before side and an after side. The left-hand side is always before, the right-hand side is always after. Now, we already found the total momentum before, so we can actually just set this left-hand side as the equation that we came up with earlier. If before the collision, the 2 carts or the 2 objects are separate, as in they're not stuck together, then we can just set the left-hand side of the equation as that equation that we found, m1 v1 plus m2 v2, which we already found was -6. But we need to figure out how the collision was afterwards in order to find the right-hand side of the equation. So we actually don't know what this is until they tell us what is the total momentum afterwards like. So let's flip the page. So to find the total momentum after, in this kind of scenario, there can be two things that can happen. So let's look at these two separately. So before the collision, the two carts were separate like this. They were running towards each other. They were not stuck together. And if they hit each other, after they hit each other, they can either bounce off and separate again, or the two carts can get stuck together. So if the two carts are separate after, then we set the right-hand side with the separate momentum equation, which looks the exact same thing. There's momentum of the first car, and there's the momentum of the second car. Except, we're going to put F here next to the velocities to show that it's the final velocity, as in the velocity afterwards. But if the two carts are stuck together after, then we set the right-hand side with the stuck-together momentum equation. So again, the left-hand side we see separate, momentum 1 and momentum 2, but on the right-hand side for after the collision, we can see that we have just one stuck-together momentum. We know it's stuck together because m1 is added onto m2. So let's try some of these equations. Okay, so let's try the following. For this one, it says after the collision, the two carts separate and the 6 kilogram cart moves to the right. So this is what happened afterwards. And it sometimes helps to draw the collision for after. So let's draw the two carts. And mind you that this is after the collision. So again, we have the 6 kilogram cart and the 4 kilogram cart. They were heading towards each other at first, but then we know that they bounce off, so we know that this one goes this way and this one goes that way. Okay, it says here a given is that after the collision, the 6 kilogram cart moves to the right with the velocity of 1.5 meters per second. And it's asking us what is the speed of the 4 kilogram cart after the collision. So we're asked to find this, which we're going to call V1 final, because that's the final velocity of the first cart. Great. So let's set up the equation again. So on the left-hand side, this is before the collision. We know before the collision there was separate momentum, and then the right-hand side of the equation is after the collision. So we have this. Great. Now we can either go in and plug everything, or we can just figure out that we already knew the momentum before. But let's plug in everything just so that you get some practice. So again, mass of the first cart is 4. The velocity on the left-hand side is the velocity before the crash. Before the crash, this one was going to the right at 3, and the 6 kilograms cart before the crash was going -3. Great. That was all before. That's the stuff that we've done before. Now let's do the second one, which is the after side. So we know here that M1 is still 4, but we don't know what this is, so we're going to put a V here, plus M2, which is still 6, and we're given the after. Remember, this is after the collision, so we put this 1.5 on the right-hand side. Great. We already knew that on the left-hand side it's 6, and then let's figure out on the right-hand side we have 4V plus this is 9. So we go through and do that. We cannot add the 4 and the 9 together. We need to get rid of the 9. So minus 9 on both sides. This would be -15 equals to 4V. And if we divide both sides by 4, we get that v is equal to negative 3 point something. 7.5. And the units, since its velocity is meters per seconds. So this is what happens if they bounce off. Let's review. Before they bounce off, they were separate. So I have a momentum 1 and a momentum 2. After they bounce off, again, there's momentum 1 and momentum 2. That's why the equation looks like this. Everything on the left-hand side is before the collision. Everything on the right-hand side is after the collision. So everything we plug in here is before, everything we plug in here is after. So let's try if they were stuck together then. If they're stuck together, we need the equation that's given to us. So let's write everything down, and it says after the collision, the two carts stick together. What is the speed of the two carts? Well, we actually have all the givens that we need, so let's plug everything together. But afterwards, the picture is going to look like this. The 4 kilogram cart and the 6 kilogram cart are going to be stuck together, and they're going to move off in a certain direction. We don't know what direction it is yet. So let's write down the equation. m1v1 plus m2v2 equals to m1 plus m2 times v final. Again, let's try to plug in everything, which we've already done before, but let's get some practice. We know all of these numbers were from before the collision, and now let's plug in the after the collision side. We know that mass 1 and mass 2 are added together, so 4 plus 6 times velocity final, which is what we're trying to find. And remember that if in an equation like this, you always should have one variable that's left blank that you need to find, or else it's unsolvable. You need one. If everything is filled out, you can't solve it. If nothing is filled out, you can't solve it either. You need one variable left. On the left-hand side, we already know this is negative 6. On the right-hand side, we have here 10 times v final. So we know that v final is going to be negative 6 over 10, which is negative 0.3 meters per second. Okay? So what that means is after the collision, the two carts are stuck together and they're going to move off to the left at 0.3 meters per second.